The summing amplifier is a very important one when used with mathematical applications requiring the summing of several different voltages. In this particular case then, it's going to take any one of various inputs. I've got 3 inputs here. It can add any 2 or 3 depending upon what the others are. And as we add these up, we'd have a total output of minus 7.5 because all these voltages are being fed to the inverting terminal. In the case of this amplifier, we have a particular point that's known as a point to summation. It has an extremely high input impedance and is often referred to as a point to summation for other voltages coming into it. Because we have inverse feedback, we're going to have a very precise way of actually adding voltages applied to the input. It must be kept in mind that the summing of these cannot exceed the power supply. So if I fed the positive part of the power supply of this circuit into 12 volts, the sum of all these voltages could not exceed 12 volts. Actually, because of a little bit of loss in the output amplifier circuit for this, probably it would be the total amount of 12 volts minus 1 volt, be 11 volts would be the peak-to-peak output of this particular configuration. Summing amplifier, similar to one that we're going to talk about, the averaging, but the resistor ratios are different for that. This is the summing amplifier.